Okay, so let's move to the next part, okay, which is a function of three variable. Okay, so this time we denoted as W lah. Okay, it can be any alphabet. Okay, so let's say we choose W. W is in term of X, Y, and Z. Okay, sorry. F is a real value function of three variables, or simply function of three variables. Okay, so we have here W as the dependent variable, and X, Y, Z are independent variable. Okay, alright. Okay, so let's look at this example. Okay, so we have here our dependent variable as a W. Okay, our independent variable is our X, Y, and Z here. Okay, let's say the first question here, we want to evaluate F minus 1, 2, 3. So in this case, basically we will have X equal to minus 1, Y equal to 2, and Z equal to 3. Okay, so we have the function of this, therefore we just substitute into that function lah. Okay, so meaning that, let's say we have the F X, Y, Z, which is equal to X plus Y plus Z. Therefore, we just substitute. X is minus 1 plus 2 plus 3. So, we will obtain 4. Okay, that one is for the first one. Okay, for the second one, we know that this is X equal to 0, Y equal to minus 3, Z equal to 1. Okay, therefore we just substitute into the F, into the W, or we can as a W. So W is equal to X plus Y plus Z, right? So 0 minus 3 plus 1, so we'll obtain minus 2. Okay, alright, so minus 2 here. Okay, so it's minus 2, it's typo here. Okay, for 3, okay, so we know that we have X equal to R, Y equal to S, Z equal to T. So we have W equal to X plus Y plus Z. So X is R, Y is S, Z is T. So this is our value. Okay, next, look at the example 2. Okay, so we have X squared plus Y squared plus Z squared. Okay, so again for equation 1, example 1 here, so we have X equal to minus 1, Y equal to 2, Z equal to 3. Okay, so since W here is equal to squared, so minus 1 squared plus 2 squared plus 3 squared, so we obtain 14. Okay, so check the answer. Yes, it is 14. Okay, so for 2, so we know that X equal to 0, Y equal to minus 3, Z equal to 1. So we just substitute W equal to 0 squared plus minus 3 squared plus 1 squared. So we will obtain 9 plus 1 is 10. So 10 here. Okay, for 3 here, okay, so we have S equal to R, Y equal to S, Z equal to T. So our W is R squared plus S squared plus T squared. Okay, so this is the answer. Okay, so now what is the domain and the range for this 3 variable? Okay, alright, so the domain for the 3 variable is referred to the independent variable, which is X, Y, Z, and the range is referred to the dependent variable. Okay, so the domain D is a set of all possible input X, Y, Z of the function W here. Okay, and the range R is a set of output that result when X, Y, Z varies over the domain. Okay, so the range is the output for the Z, and the domain is the input for the X, Y, Z. Okay, Okay, so let's look at the example 1. Okay, so we want to determine the domain and the range for this f. Okay, so we know that, oh, here is the square root. So in order to find the domain, of course we need to look at the restriction. What is the restriction for the square root? Okay, so we know that the restriction for the square root is must be greater or equal to 0. Okay, therefore this is our domain. Okay, subject to the independent variable. Okay, such that x squared plus y squared plus z squared greater or equal to 0. Okay, so that is our domain. Okay, so now the second one, how we want to determine the range. Okay, so if you look at the domain here, okay, the domain here is x squared plus y squared plus z squared greater or equal to 0. Okay, so it's always positive. Okay, it's always positive. The minimum value is 0. Okay, so meaning that here, if we substitute the value of 0, so it will be 0, and then if we substitute the value of 1, it will be greater and greater. Okay, so the minimum value is 0. Therefore, what we can say here for the range is, okay, for the dependent variable z, okay, the z is greater, z is w this time, yeah, sorry. We use w because w is equal to fxyz. Okay, the dependent variable in this case is w. So w, okay, w will be greater or equal to 0, because if we substitute the value for the x squared plus y squared here, the value of w always greater or equal to 0. It won't be negative. Okay, because we already said that the value of x squared plus y squared plus z squared is greater or equal to 0. Okay, so that's why the range is also w greater or equal to 0. So if we use your calculator, if we choose any value of x, any value of y, any value of z, the value for the w won't negative. It's always greater or equal to 0. Okay, alright, so next one, example 2. Okay, so this one, we want to look at the domain and the range. Okay, so we have our independent variable as usual, x, y, and z. Our dependent variable is w lah in this case. Okay, so we need to, for the domain, we need to look at the restriction. Okay, so for this case, since it is square root again, so we can put it as the restriction here, greater or equal to 0, right? Okay, therefore from here, so we know that it is basically x squared plus y squared plus z squared. Okay, so we can rewrite like that, and then okay, so we can write the value here lah, y squared plus z squared, so negative, so it will be 1. Okay, alright, so therefore the domain, okay, for the dependent variable x, y, z, such that x squared plus y squared plus z squared less equal to 1. Okay, so we can write as this, or we can write like this. Okay, so I love to write this way lah. Okay, but this one also can, doesn't matter. Okay, so now we want to find the range. Okay, the second one is we want to find the range. Again, we know that, okay, so for this case, we have x squared plus y squared plus z squared, which is less than or equal to 1. And we know that for if any value of x, y, z, when we square, it will be greater or equal to 0. Okay, so it will be between 0 and 1. So we can set for the range. Okay, so for the range, we just substitute into the value. Okay, if we substitute into the value w here, so we know that the part here is either the minimum value is 0 and the maximum is 1. So let's say we choose 0, so we'll have 1 minus 0. So we will obtain 1. Okay, and let's say if we choose the value of 1. Okay, 1. So 0, 1 minus 1 is 0. So we'll obtain 0. So meaning that the range here is, sorry, we use the denotation here again, so the value will be for w, okay, w, the maximum value is 1 and the minimum is 0. Okay, so just imagine for the range, we just substitute in the value here, and we choose we use your calculator and calculate. Oh, the value is only between 0 and 1. Okay, so this is our range. Alright, example 3. Okay, so again we want to determine the domain and the range. Okay, so of course again, so our independent variable is x, y, z, so it is three variables, and our dependent variable is our w. So again, if you want to find the domain, we need to have the restriction. So what is the restriction for the fraction? Okay, of course the restriction is for the df for x, y, z is what? X plus y plus z cannot equal to 0, right? Because we have the denominator here, the fraction under the fraction below cannot equal to 0. Okay, if not, the function will be undefined, isn't it? So that's why our domain is this one. Okay, so now what about the range? Again, we use a calculator. Okay, so we just substitute into the value. Okay, so if you use any value, okay, so of course it can be negative. Okay, it can be negative, it can be positive, but it cannot equal to 0. Therefore, we can say that w cannot equal to 0. That is our range. Okay, because this is w, we just take any value of x, y, z. It will be 1 over negative, 1 over positive, but it won't be 1 over 0. Okay, so that's why w, okay, cannot equal to 0. Okay.